Alright guys, welcome periods 1, 3, and 4. I miss you guys so much. I'm excited to be able to do these videos though. And just be patient with me, and I'll be patient with you as we go through this process. This is the first time that I do a full lesson on Desmos and record it. So let's just get right into it. Okay, so there was two steps that I asked you to do in Schoology. One, open up this video link, and you're gonna be pausing. I'm gonna ask you to pause this video while you go back and forth to the different tabs between the video. And the second step was to open this link for the Desmos lesson. So you should be going back and forth between your two tabs. Now, when you join, it might say your name up here, it might not. That's okay because this says my name because I have an account. If you don't have an account, I don't think that you need to have one. I think you could just join. And if it asks you, just join with Google. That's fine. That's probably the easiest way to do it. So I can join this lesson. It's going to ask you for your name. I already joined it, so it automatically asked me to join using my name. So you could type in your name. Please use your full name. This is how you're going to get credit for this lesson today. All right, so lesson 1 is called Rigid Transformations in the Plane. And the goal for this lesson is let's try transformation with coordinates. Now, there's some words here that are very familiar that we talked about at the beginning of the school year, and though that is rigid transformations. Now, at some point in time, I think I'm going to ask you to remember what those transformations are. But let's remind you we have translations, rotations, and reflections. And then we started talking about dilations, and I said that's another transformation. It's just not a rigid transformation. Um, so it says, let's try transformations with coordinates. Now, let me remind you that a plane, or therefore a coordinate plane, is actually, we could think about it as a graph. So we have our x and we have a y graph here. And this is what a coordinate plane looks like. So if they're talking about transforming with on this plane, this might be something that we already know. Let's say we have a box or a square, and they want us to transform this. Maybe they want us to reflect it, and it might land over here. So it's what we already know, except the difference now is we're using this coordinate plane here, an x and y axes. That's it. So let me go back to the lesson. Let's go to the next slide. The warm up. It says, how far away is point A from point B? Now, let's zoom in on this graph for a second. They want to know, how far away is point A from point B? Well, if you already have an idea, by all means, but I'm going to give you a little tip here. I'm going to try to use this ruler. Now I will never draw a crooked line again. But if you see, oop, I didn't go further enough. Wow, maybe I will draw a crooked line. Well, that's fine. We get the idea here. So I'm thinking like, okay, how am I going to figure out how far away A is from B, right? If, I don't know this distance right here. What is this distance right here? That's what I want to know. Well, I see if I connected all these together, I have a triangle here. And now this looks like, wow, hey, this is a right triangle. Do you see this angle right here? This is a right triangle. What skill do you think we're going to be able to use to figure this out? Hopefully you said Pythagorean theorem because, right, Pythagorean theorem only works for right triangles. And if you see here, we could actually figure out the two side lengths. So the distance from here to here is 1, 2, 3. So this distance here is 3. This distance I know for sure is 1, 2, 3, 4. These are two side lengths that I know for sure. But that's not the one they're asking us for. They're asking us for A, B. But we could figure out A, B by using the two side lanes 4 and 3 using the Pythagorean theorem. So, who remembers the Pythagorean theorem? Hopefully you said, I do. And so remember that that's a squared plus b squared equals c squared. Remember that c squared can only be what? Your hypotenuse, and a and b are your legs. So we found the legs. We know that the legs are 4, and then we said square that, and 3 squared. C squared, my hypotenuse, that's what I'm trying to find. I can leave it as C squared. So I set you up for success here. Go ahead and pause me and figure out the rest of your, keep working this problem out and go ahead and type your answer into Desmos. All right, so by this time, you should be back in your video and you should type in your response here. How far away is point A from point B? I'm going to make up a number. This is not the answer. I repeat, this is not the answer. I'm just going to put blah, blah, blah. Okay, you tell me what your answer is, and then you hit submit. Explain your thinking. Tell me, why is that the answer? Blah, blah is the answer because, and then you can tell me something there, and then you hit submit. Okay, once you're done submitting, you can hit next up here, and then you keep going through. I have one more question for your warm-up. Is it 2 questions? 3 questions? 2 more questions for warm-up. The second question, what are the rigid transformations we discussed at the beginning of the school year? Think back or rewind back, and I did mention what those were already. So go ahead, type your response here, blah, blah, and hit submit. Don't forget to hit submit or I can't see your answers. Third question, what transformations will take point A to point B? So I want to know, oopsie, how can I transform and get point A all the way to point B? So go ahead and type your response here and tell me, maybe you're gonna translate and then rotate, or just translate or reflect or translate only, but tell me which direction you're gonna go. You're gonna go left, or you're gonna go right, or you're gonna go up, or you're gonna go down. Be descriptive in this response. Okay, so you can pause me and share that. And then hit next. Activity 1.3. So we're going to skip second activity and go to this activity here. So this is saying that first you will determine some measurements, then you'll answer some questions, and then finally we're going to have a class discussion. So go ahead and move on to this part of the Desmos lessons if you're done with the warm-up. And the directions are saying, calculate the length of each side in triangles ABC and DEF. Now, what I want you to do here is hit here, and there's a couple sides here that you need to figure out. So, how I want your response to look is you could say FE equals, well, what's the distance of FE? You can zoom in and count how many spaces is F away from E. That's 1, 2. So FE is equal to 2. Then you could tell me ED. ED equals what? And now you're going to want to tell me FD. Now, here's the thing. FD, we can't just count the FD spaces like we were able to with F and E. What you need to do is use the Pythagorean theorem, just like we did in the warm-up, to solve for FD. Do the same thing for AB, AC, and BC. And once you're done, you'll share with the class, you'll submit your answer, and move on to the next one. Same thing here for number 2. They say the triangles are congruent. How do you know this is true? Just type in your response here. Type up a response. Remember, I'm not always looking for you to be super, super correct. I just want to see that you tried it. So go ahead and tell me, how do you know that these two triangles are congruent? They're telling you they're congruent, but how do you know? Tell me a good summary of how you know this is true. Number 3, Because the triangles are congruent, there must be a sequence of rigid motions that takes one to the other. So remember that if two triangles are congruent, that must mean that there exists some kind of sequence to get one triangle to lay right on top of the other one. So what that question is asking you here is find that sequence of rigid motions that takes ABC on to DEF. So describe to me in, descriptive steps. First, I'm going to translate point A to point D, and then I'm going to reflect, or then I'm going to rotate. But if you're going to say those things, remember you need to tell me how many degrees are you going to rotate? Where are you going to reflect this? What line are you going to go over? I'm not sure if that's actually the answer, but those are some of the things that I want to see you write in here. So go ahead and work on that. And you can pause me throughout each number. I'm just kind of going through these because I'm assuming that you can pause me, rewind me. That's the only cool thing about this. You can go at your own pace. Finally, when you're done with that, you're going to go to the cool down. They're saying triangle A prime, B prime, and C prime is the image. Ooh, image. That's is that one? Did that one come first or did that one come second? A prime, B prime, C prime is the image of triangle ABC after a sequence of rigid motion. So they kind of answered that question for us. Find a sequence of transformation that takes triangle ABC to triangle A prime, B prime, C prime. We're asking the same type of question that they did for number 3 over here. Second question and final question of this lesson for this cool down are, what are your thoughts on this lesson alongside with the video? Do you prefer this or Khan Academy? Let me know some feedback and then submit and you're done for the day. Thank you guys so much. You're amazing.